Yes, that's right, Jasper. I had the pleasure of be a co-author of a Norwegian book in innovation, together with among Kristine Lundberg Larsen, as you know, and also Katrine Barth, as we saw on the wall, and that was a reminder for all the authors that was participating in that project. What I'm going to talk about today is somewhat different, because the oil and gas industry and what you also represent in Equinor, their coming renewable energy sector, is part of an industry infrastructure that we might not identify or think about in our daily work. So I'm going to show you a little bit of this, but I have to just to tell that I'm working in Equinor, and that used to be Statoil. A lot of us says that changing name from Statoil to Equinor was just a change of clothes, but it's not. It's a change of strategy as well. So we have a real ambitious strategy to increase the business in renewable energy in the coming years. So that we have to take into account when we are planning new renewable energy activities, that will sometime end up as scrap or something to reuse, and it also contains of valuable materials that I come back to later. We are obligated to some sustainability priorities. We are committing to the UN's Sustainable Development Goals, and I have to say that this is under development. What is the impact of this in real time? So the strategy people at Equinor are working hard with this, and we also have a sustainability report that is open, that you can read to see what Equinor is thinking about sustainability in our value chains. Okay, this is maybe one way to see value chains for our part. We have raw material, we have some material processing, manufacturing use. We are mostly in this part when we buy equipment or build oil platforms, or build offshore wind farms, or building onshore solar panels parks. But at some time we have to come to this end of life phase, where we have to have some plans. What do we do with this? It's huge amount of scrap, as I show you. So this is only it's not a part of our strategy. This is a picture borrowed from the IRENA, the International Renewable Agency, and I think it illustrates very good some of the important parts that we have to take into consideration, and also what is said earlier here. The producer, distributor, consumer, and recycler have to have some cooperation. It has to be a communication and cooperation throughout the value chain. So now I'm going to tell you what is industrial infrastructure, if you didn't know. And for us, industrial infrastructure is a lot of things. It's valves, it's pipelines, it's flanges, it's small parts from the process plants that we have. It is larger parts of process plants, and it's large process plants onshore and also offshore. This is a Statfjord A platform in the North Sea that is going to be decommissioned in 2.5 years. That's a huge construction. It's about as high as the Eiffel Tower, and it weighs about almost does 0.2 missing is nearly 50,000 tons of steel. And a lot of the steel, at least coming from the platforms or the process equipment that has been in contact with natural gas, has some content of mercury on it. So it's light contaminated with mercury. And that's an additional challenge for us. I also added this solar PV plant that we have in production now in Brazil. It's a rather huge plant. It has 500,000 solar PV panels on 414 hectares. It takes area, and it's a lot of value in the panels at the time where they are going to be decommissioned. There's a lot of valuable materials left in the panels. And we also have a lot of offshore wind parks. This is a wind park outside the east of England called Dudgeon. And it's a large wind park, and it consists of 67 wind turbines. And we also have plans to expand into the Dogger Bank area, and that's about 2,000 windmills total. So how do we handle and recycle, or what do you think about handling, recycling, and management these offshore installations? Here's some examples. We have already started. The oil adventure in Norway started in the early 70s, and it's now in a midlife position. And we have started to demolish and take to shore parts of it. This is Troll oil gas injection templates that was placed on the seafloor at the Troll field. And here we have some loading buoy, oil loading buoy. And as you can see, it's large constructions. It consists of a lot of steel, and it's very complicated to take this onshore to handle it on a way that is sustainable. And also the surplus value chain here is very important to inform what do they get when they get this equipment. Is it contaminated? And what's the risks to receive all these things? Okay, so I just three other examples on platforms and installations that are scrapped, and as you can see, it's almost as difficult to take this back to onshore that it was to place them offshore, because you have to rely on the weather all the time, and it's heavy lifts. It's very risky. So, but we have some experience with this now, and also here, smaller part of process equipment are changed on regular basis, on regular operation and maintenance schedules, and that also is a risk not only for the environment but also for the working environment. The guys that are cutting these parts into smaller parts so they can go to a recycler. So it's very important to be aware of the risks of the quality and the contamination risks that we always have on oil gas installation parts. So this is what we think could be a good solution, and this is what we do today. But we are thinking about improving this value chain, scrap value chain. Here we see the offshore installations, or part of it. They are transported into the remelter. This is what they do at the Celsa armeringsstål in Mo i Rana, and they are melting the scrap. They are blending scrap. They are actually manually blending each batch of scrap that goes into the furnace. So this is handcrafted by machine, of course, but it's the mixture that they are putting into the furnace is made by hand. And the steel coming from the offshore installations is very, very high quality steel, and they really want to have that quality into their process to extend or enhance their end product. So they melt it. They make some bars coming out of the furnace here. At the 1200 degrees centigrade, and it ends up as construction steel. So you can say, is that a higher value on that it was initially from the offshore installation? Maybe. Construction is also, and building a new infrastructure with steel coming from offshore installations is also a part of a value chain and a value creating chain, I think. So just an example on a pre-project proposal that we are working with at the moment is to do a full-scale trial on the CEC19 Nordic in Mo i Rana to blend in our steel coming from the offshore installations directly without any cleaning procedures or something, which is very costly. It includes storage and possibility for leakage of contaminants that are on the parts and on the steel. So if you can ship the steel directly to Mo i Rana and they blend it in their melting process, having control of the emissions from the furnace. They control on dioxins, they control on mercury. So the plan is to do a pilot trail maybe next year on that to see if that will shorten the value chain, the length of the value chain without altering the quality of the value chain. So we don't want to be a company that is leaving the scrap in Mo i Rana, increasing the contamination in the area. That's not a good solution for us. So what we want here is a sustainable end-of-life development for a low mercury contaminated steel scrap and equipment from the offshore constructions. So I think we are planning this now along with the SINTEF MOLAB, NOROG, which is the organization for Norwegian oil and gas companies in the North Sea, and also, of course, with the CEC19 Nordic in Mo i Rana. We have some meeting, and all parties are agreed that this is a good idea, and we should try it. We should make a project to see and to identify risks and possibilities here. Okay, so I'm going to change the scene, and I'm going to tell you a little about our renewable portfolio. And when I was heading the renewable energy R&D program some years ago, we made some LCA analysis of offshore wind and presented them to the business unit for new energy in Statoil, and that was not very popular. Can I show you? But I think it has been matured some, and I think that the mindset of the business developers has changed a bit, and also because the circular economy is coming more and more into the business models. I will focus on solar. As I told you and showed you, we have one solar park operating in Brazil, and we have a park under development in Argentina. And we have also some other parks in pipe. And the Brazil solar park is also, it's a large park. It's not what you think about solar panels on the roofs or on a cottage or something. This is industrial scale. This is 500,000 solar panels. It is in the area, and the area is about 140 acres. It's a large plant. So this is industrial scale, or utility scale, as we call it. So we also think that the circular economy principles have to be applied on this kind of industry. So we are trying to massage this into the business developers in the new energy division to convince them that they have to think about the end of life management already now. It's no use in 10 years. Even if a solar park can last for 30 years, you have to have plans for this, as well as we have for offshore installations. If you have an offshore installation now, you have to have plans for how to decommission this installation when you start it. And so you should have on all the industry scale plans that we have. And also because solar PV parks represent a huge amount of valuable materials that can be reused. Okay, this is a table from IRENA again, showing the huge or the exponential growth in solar PV waste in the coming years. As you can see now, as you can see now, we are about between 43,000 and 250,000 tons. It depends on two different scenarios that have been done, and that's connected to the lifetime of the solar panels. Is 30 years or less than 30 years? And if the scenario is less than 30 years, it represents the highest amounts of this e-waste. So we see in some years this the waste coming from solar PV is growing exponentially, and there is no technology to handle it today. And why does solar PV panels last shorter than the design, what is designed for? And here is an analysis of that that IRENA has made. Some is unknown, some is transport damage, defects, cell interconnection, power loss, glass break. It's everything can happen. And also here is a figure showing that the value in a solar panel is, if you take copper and silver, is almost 60% of the value is represented by copper and silver. So, and again, that represent an amount of these metals that will reduce the need for mining new copper and silver, and that also have a good influence. Okay, just an example. This is silver. This is actually stuff coming from Kongsberg Gruver mining in Norway, which is well known for its gene silver, and IRENA says that silver recovered from PV panels has a significant value, and if you recovered 90 tons of silver in 2030, this will represent enough to produce 50 million new panels, they say. No, it's blinking red here, so no, I'm out of time. So I just have to say that a wafer, a solar panel, is very complex. It's made very complex. And I think that the designer of solar panels in the future have to have to design them to be recycled. They're not today. Okay, then I jump this, and my takeaway today is scrap is gold, actually gold. So that's my takeaway at least. So thank you very much for listening to me.
Thank you.